In this video, we are going to talk about a question by daily coding problem. Implement a job scheduler which takes in a function f and an integer n and calls f after n milliseconds. I am just simply writing a function def scheduler which takes a function as arguments. I am using type hinting. Type hintings are great actually for documentation. Time.sleep, time number of seconds, and we are going to run the function. We will also define a function share.py. Okay, after 5 seconds we are getting this output that this is a welcome function, so our scheduler is running properly. But with the current implementation, the problem is after scheduling this program, our code is actually blocking. It is not going to take another function and do the same. If suppose I have another function and if I run it, we will see the output. So here you can see we are seeing the output of first function and second function. Now if suppose I have a function with sleep time 2 and I am going to run it. So the problem is that even though our welcome function is taking long time to sleep and our second welcome to function is taking just a small value, our implementation is not taking this into consideration. It is just running the function by taking that argument. So we need to solve this problem. So how can we solve it? What is the use of this scheduler function? I mean, who would want to implement such a thing? Let's take a look at our you can see that there is something inside our operating system which is known as CPU scheduler. So what our CPU scheduler do is it actually takes our processes or our program that we want to run. Suppose my thought.io is a program inside my MacBook and I want to run it. Now since I click on this icon and I want to run it, this process is in a higher priority. Our CPU should execute that program and show us the output. So that's what is happening here. Actually, when I am showing you this diagram of CPU scheduler, it is actually being currently implemented in my system. So now let's understand what CPU scheduling is. In CPU scheduling, there are multiple processes that need CPU to be executed. So here you can see that new process is arriving, it is going into a ready queue, and after the ready queue it is going to be dispatched and get executed in this CPU. And if suppose it is requiring some input output time, it is passed to IO subsystem and next processes will just take CPU time. Similarly, our question is expecting us to give a function with time to sleep and after that it should get executed. Take a look at our current implementation. If this is the implementation that we are going to use, what will happen is if a process is actually sleeping for 5 seconds, then there is no mechanism by which, okay, I will run this process later. Instead, execute for 5 seconds, it will sleep for 5 seconds, after that it will execute and again it will execute the second function after sleeping for 2 seconds. Actually, our sleeping call is blocking. So how can we take advantage of that and try to come up with an implementation that does not have this limitation? So queue is a data structure. It is similar to list in Python, but the main thing is that it contains certain pointers to it. So in queue, the limitation, or I can say the feature, is that data can only be entered from one side and exit from a different side. So when you go to a train station or airport, you are in the checkout line. So if you come early, get your tickets first. So it is a first in first out mechanism. So if you go first, you will come out first also. So that sort of implementation. So insertion will happen on the front end and deletion will be happen from the back end. Why I have put this PCB1, PCB2 here? It is actually the value inside this queue. So earlier I showed you some queues that were used by CPU scheduler. They actually use this PCB data inside the queue. So PCB data generally contains our process ID, process states, and the priority, program counter. All the things that a process needs to execute in our system is generally contained in the PCB. So when the CPU schedules it take a PCB, execute it, and after executing this PCB, this will just get destroyed. Along with that, in the PCB itself, we have a process priority information by which the scheduler knows what is the current priority of our process and which process should I execute first. In our program, the current limitation is that we have two functions, welcome and welcome to. But our current implementation doesn't take this into account, it just executes it in one go, and hence we are facing this issue. What we can do to solve it is that I am going to write another class, that is job scheduler. I will implement a init function there, okay, and I will create a self.jobs, and I will create a def schedule method. Actually, what I can do is Control Z. I can take this function itself, the scheduler function, and I can just I will take it and I will type here, okay. What we will do is we will actually use a module in Python called heap. From heap_q import heap push. So I will tell you why we are going to use it. Then we are going to have a run method that takes self as argument, and we have implemented a scheduler class that is simply taking the functions and putting them into a list, and after that I am going to iterate over that list and take one program at a time and executing it. If you try to run this, here you can see that our scheduler is actually working. It supposedly take the function which is taking less time to sleep. This is welcome to function, and after only that it is executing this second function. So there is a corner case here. What is that? If I try to give like same number to both of the program, we should expect the error. Here you can see that it is saying that less than is not supported between instances of function and function. So what this line actually is doing, that it is like comparing the values. It is comparing the values that are already in this self.jobs list. So here the n value is there. If we give both of these values same, one is 5 and second one is also 5, so it can't decide to give a priority on basis of that. So it is going to move to next item in the list, that is a function, and inside this function this operation less than is not supported. That's why we are getting this error. So one way that is mentioned in the heap_q module itself in Python is we can use a sort of count variable to tackle this. One thing to note is that it is supposed to move in sequence. First it will compare n, after that it will compare self.count, and after that if both of these value matches, it will compare this function. Now we are making sure that this self.count value will never actually get modified by the user. We are internally handling it. If I try to put this function before self.count, then we will always get into this type of error. If I try to run this program again, we should. One more thing we need to change is that since we are pushing 3 values inside that, we need to like get a throwaway variable, and yeah, we should see the output. So this is the output that we are expecting. If we add another welcome to with priority 2, so it will technically run that function first. So yeah, you can see that it is running. This is welcome to first, and after that this is welcome function is running, and after that this is welcome to should run again. So yeah, our program is working as expected. this from typing import callable is used as type hint to our function. So this is our implementation of the job scheduler class. Thank you guys.